graphs of the form y equals mx plus c. So we can use this general formula to describe any straight line graph. M, or the number in front of the x, notice it's always attached to the x, but it's not the x itself, it's the number in front of it. So m represents the gradient of the line. And we know that gradient is equal to rise over run. C, so if there is a number on the end here, the C represents the y-intercept, or where it crosses the y-axis. So if I were to look at y equals 3x plus 2, I can see that it has a gradient of 3. It has a y-axis, or crosses the y-axis at this value, positive 2. Let's look at this example down here. So y equals 3x plus 2. We are expecting it to cross the axis at 2, which it does, and have a gradient of 3 over 1. 1, 2, 3, 1. There we go. Our second example, y equals 2/3 x minus 4. So this time the gradient is 2/3, and it crosses the y-axis at -4. And again, let's just double check. We can see it crosses at -4 and has a gradient of rise 1, 2, run 1, 2, 3. So if we're to draw a straight line graph, we can use this method to help save time, and so we don't have to draw a table of values as we did before. So what we would do would start with the y-intercept. So you always start with the y-intercept as your first coordinate. You then use the gradient, or the rise over the run, to plot 2 further coordinates and join them up. Now always remember to extend in either direction. That shows that you've only drawn a portion of the line, but you're aware that it keeps going on forever. So here are some examples. So firstly, y equals 4x minus 1. We know we're going to start this line at the value of -1 on the y-axis. So we find -1 on the y-axis, and we draw a point. We then look at the gradient. So the gradient I can see for this question is 4. Remember, we need to have a gradient as a fraction, so this would be 4 over 1. From this original point that we started at, we're now going to use that to draw a line with gradient 4. So we know that if this is our starting point, we're going to rise 4, 1, 2, 3, 4, and run 1. And we're going to repeat that, 1, 2, 3, 4, and run 1. And there is the line y equals 4x minus 1. Our second example. This one has no number here. It just has 1/2 x. That means that our y-intercept is actually 0. So our starting point for this graph, this line, would be the origin at 0, 0. We see the gradient is 1/2, so that means rise 1, run 2. So from our origin, we rise 1, we run 2, and put a point. We rise 1, we run 2, and again. And we would join those points up. The next example. This one is going to start at -2 on the y-axis. We're all getting a bit close together. So this is -2. And we are have a gradient of 2/5 this time. So 2/5 is our gradient. So from that point -2, we're going to rise 2, run 5. Rise 2, run 5. 1, 2, 3, 4, 5. And rise 2, run 5. And there we go. So this one is y equals 1/3 x plus 4. So we're starting at plus 4. 1, 2, 3, 4. And our gradient is 1/3, so it's rise 1, run 3. Rise 1, run 3. Rise 1, run 3. Y equals 3x. Again, our y-intercept, there is no number, so we're going to start again at 0. And our gradient for this one is 3, so we need to have that as a fraction, so it'll be 3/1. So we're going to start this one at 0. And we're going to rise 3, 1, 2, 3, run 1. Rise 3, 1, 2, 3, run 1. And our final example for this group is y equals 2x plus 1. So we're going to start at positive 1. And we have a gradient of 2. So we need to have that 2/1. And we rise 2, 1, 1, 2. And we run 1. Rise 2, run 1. Now, very rarely will you be asked to draw so many graphs on one set of axes. And I would suggest that you avoid doing so wherever possible, because as you can see, it gets a bit confusing.